Hello friends, this is Shubham and welcome to my YouTube channel. Today in this video we will be discussing about a very important interview question, that is implementing TF-IDF algorithm from scratch. This has been asked to me in several data science interviews, and we will be talking about that in this video. Okay, so firstly, why we are using TF-IDF? There are multiple techniques of text vectorization like bag of words, TF-IDF, and word to vec, then TF-IDF, weighted word to vec, average word to vec. There are many techniques. Yes, we can apply all those. Okay, but in interviews, since the TF-IDF algorithm is a little bit easier to implement from scratch, so it is mostly given in interviews. Okay, and it is slightly better than BOW, that is a bag of words, because BOW, I'm talking in short form, so BOW does not hold much semantic relationship among the words because only 0 and 1 is used to encode the text. Okay, but in TF-IDF also, we don't preserve the semantic meaning between the words. Like if you take tasty and delicious, both are having same meaning, but TF-IDF will consider them as different words. So it might be a little advanced algorithm than BOW, but it does not preserve any semantic meaning. This semantic meaning, this semantic relationship, is preserved in like word to vec models and average word to vec, TF-IDF word to vec. All these are like advanced algorithms. Okay, so in this video we'll be discussing only in like TF-IDF. So let's go to the documentation and check that out. Here is the documentation of TF-IDF, and here you can see, okay, this is not, we can go to TF-IDF vectorizer. Okay, and yeah, this is documentation of this one. Okay, so TF-IDF, what it does is it gives, if we give an input to TF-IDF vectorizer, like we give text input, okay, and it gives out vectors as an output. So actually what it is doing is it is vectorizing the text documents. So if you have a text feature, then you probably will use these algorithms like TF-IDF, BW, word2vec and all. So it will help you in converting that text into vectors, because the machine learning algorithms or deep learning algorithms only understand numbers, that is vectors, in the form of vectors. Okay, so let's understand this with a little example. Okay, so here we have get a presentation on this. Okay, let's start. So we'll take three sentences into consideration. Okay, sentence 1 is goodbye, sentence 2 is good girl, and sentence 3 is boy girl good. So TF, that is term frequency of TF-IDF. Okay, so it is equal to the number of repetition of a word in a sentence and divided by the number of words in a sentence. So term frequency actually says is what is the probability of finding a word in a document. Okay, so according to this, if we substitute this in this formula, then we will get this table. Okay, this one. So okay, so here we can see is we are getting 0, 1 by 2. How we are getting this one? So if we find like in sentence 1 for girl, okay, so we are getting no instance of a girl here, so it will be 0. Okay, in sentence 1, in sentence 1 we have one good and one boy. Okay, so here we get 1 divided by 2, because one occurrence of good divided by total number of words in sentence 1, that is 2 words, so 1 by 2. For boy also, one boy and divided by 2, that is the total number of words in a sentence. So like this we will fill the entire table here. Okay, for the TF. Similarly, you can see in sentence 2 we are getting 1 by 2 for girl. Why? Because here we have only one instance of a girl in sentence 2. Okay, here, and so 1 divided by the total number of words, that is 2 in sentence 2. So in sentence 3 you can see that it is 1 by 3 for girl. So here see, you have got one instance of a girl in sentence 3, but we have 3 words in sentence 3, so 1 by 3. So after filling we'll get the TF matrix. Okay, from this then we'll calculate the IDF, that is the inverse document frequency. So IDF is equal to the logarithm of number of sentences divided by number of sentences containing the word. Okay, so look at the girl. So if we see girl, then girl is present in 2 places. okay. And okay, so how many sentences are there? Number of sentences, we have 3 sentences, right? Sentence 1, sentence 2, sentence 3. So log of 3 sentences divided by how many sentences girl is present. So it is present in 2 places, so 3 by 2. In so similarly for good, so good is present in 3 places and number of sentences is 3, so log 3 by 3. And similarly for a boy, that is boy is present in 2 sentences, sentence 1 and sentence 3, okay. And total number of sentences is sentence 1, sentence 2, sentence 3. There is 3 sentences, so log 3 by 2. Now after this we'll calculate just the TF IDF, that is we'll multiply, that is TF into IDF, okay. So we'll get this one. See, for sentence 1, okay, so it is sentence 1 is this part, okay, this part. So 0 into, for girl we are finding, okay, so 0 into log 3 by 2, okay. Then 1 by 2 into log 3 by 3, then 1 by 2 into log 3 by 2. So we are multiplying this in like this in column wise, okay, for both. So for girl, for good, and for boy, we'll do the same thing for all the sentences. So after multiplying, we'll get this type of matrix. What we'll get as like the value we will see in code after some time. So I think we should directly jump off to implementing it from scratch, okay. Okay, so let me open my terminal. Okay, so we need a clear screen. Okay, so let's go to Jupyter Notebook. Okay, it'll take some seconds to run it. We can wait. Sure. Okay, so we will do this a new Python 3. Okay. Okay, so here we will be implementing the TF-IDF vectorizer from scratch. So let's start. Okay, we'll take 3 documents into consideration like we had in this. So let's see, sentence 1, goodbye good girl and boy girl good. Okay, so we have doc A is equal to goodbye, doc B is equal to good girl. Okay, since we are giving a double, so that doesn't create conflict after this. Doc C, we have boy, girl, good. Okay, so okay, sorry. Yeah, ready to go. So first, what we need is like we have to find out the term frequency, and then we'll find out IDF, that is inverse document frequency, and then we'll hop on to TF-IDF, that is multiplication of both the tables, both the matrices. Okay, so let's go. That is, IDF is not a matrix, it's just the IDF value for each word, unique word. So first we will split this and store it in a list. Okay, so let's see, doc A dot split. We will split it using this paste. Okay, I'm gonna copy paste this so that it is done for all the 3. Okay, then we'll go to bow C, doc A, doc B, and doc C. We are splitting it most probably. Okay, then what we'll do is we'll create a word set out of this. Okay, like it will contain all the unique words. We'll remove all the duplicate on the redundant words. Okay, so we'll take a set of BOWA. Okay, dot, we'll take all into consideration. So we'll take a set of BOWB. Okay, dot, again a union of BOWC. Okay, so we got this. I think there is, okay, I forgot to take this set here, right? Set of this one. Close both the brackets here. That's probably, yes. Okay, so we can print this word set and see that we are getting all the unique words or not. Okay, so yes, we are getting a boy, girl and good. Yeah, we are getting all the three words. Okay, no problem. Now what we can do is we will increment and see. What we are finding is whenever we are finding the the probability of a word in a document, like the term frequency. So we have to find a frequency of word in a sentence. So okay, so we will keep a counter and we will increase that counter whenever we come across the same word. Okay, so we will create a word dictionary. Okay, uh, okay, sorry, is equal to dict dot from keys. Sorry, dot from keys. We'll take the word set, comma. We'll keep the default value as 0, and we will just copy paste this. You know, the best way to be a good programmer or a good software engineer in industries is to know three mantras. That is copy, paste, and find. Control C, Control V, and Control F. Okay, so we are getting this one. So these are empty actually. So okay, next we'll be incrementing it, right? So for word, okay, in BOWA, word dict, where is that word? Dict A of word plus equal to 1. Okay, now we'll do this for all this and this. So we'll get for each and every sentence right out here. Okay, and this one for C. Okay, we'll change these also. Cool. So let me run this. Okay, yeah. Now if we see all this, what we are getting as a result. So we'll take word, yeah, Control C, Control V, Control V. Okay, right. So yeah, you can see all the instances of this right now. So in first sentence you can see good and boy, no girl, and this we can get it from this. Okay, just the BOW thing we are doing here. Okay, so next part, let's go. So we have calculated this one. Now we can find out the term frequency out of this. Okay, so as we know the formula, so let's give a name, compute TF. Okay, we'll take the word dict, comma, okay, and we'll do a TF dict, just the empty dictionary here. Okay, so every time we are gonna take a count, that is, this is the length of the BOW, that is the length of the sentence, because we have to divide it with the length of the sentence, right? So in a sentence, like, you have to find like here you can see here. So how did you get this 1 by 3 here? Because the length of the sentence was 3, so divided by the length of the sentence, and the occurrence of girl, that was one time in this sentence 3, right? So here we are going to do the same thing here. Okay, so we're gonna take this one as bow count. Now we'll iterate, okay, from this and count in word dict.items, like we are iterating the dictionary here. Okay, so what do we know? We know that TF is equal to number of repeating words, sorry, in a sentence, okay, divided by the total words in a sentence. Okay, so we will just do only the same thing here. So TF dict word is equals to count divided by float of bow count. Simple as that. Okay, and we will just return this is a dict. Okay, So we'll be returning this one again. Tf dict. Sure. So we are done with this function. Okay, let's test this out. Okay, so let's see a tf for the a is equal to commute tf idf, sorry, tf, and then we'll just pass this vertex, this, and the bow length. So bow a, same thing we are gonna do for all. This is gonna be a b and this is gonna be a c. This is pretty much very easy to implement. Okay, so here, so let's print out and see what we are getting as the input. So tf and of sentence 1. Okay, we're gonna see this one as tf idf tf Bowie. Okay, so let's go for sentence 2 and 3 as well, so that we can see what are the results. Oh, sorry. Okay, it's a B and it's a C. Okay, yeah. Okay, yeah. See, this is 0.6 is wrong, absolutely wrong. Where I made the mistake. Okay, so here it will be bow B and here will be bow C. Man, these small mistakes like take your breath away every time. So yeah, here we are getting the TF of all, right? So right, because see, you're getting 0.5 0.50, so it was for a good 0.5, boy 0.5, and girl 0 for sentence 1. So here the same thing you're getting, right? For sentence 1 0.5 0.5, and for girl it is 0. Similarly in sentence 3 you are getting 1 by 3 1 by 3 1 by 3. Okay, so here also you can see 0.33333, you're getting this result. So we are gonna go in the right track. Okay, now it's actually a time to implement IDF. Okay, so df compute IDF. Okay, so we will take the entire list into consideration. Okay, so we'll take a corpus list. Okay, a doc list. Okay, so let's import math because we'll be doing a logarithm this time, so it will be inside a math. So diff, we are taking an empty dictionary can. Okay, and n is equal to the length of this doc list. Okay, so at first we will have like this. Okay, a girl 0, a dictionary actually, good 0, and boy, that is 0. Okay, I forgot to put it in the quotes. So idf dict will be equal to dict dot from keys doc list of 0 dot keys. Okay, then we'll just initialize them to 0 for the first, and then we'll run a counter and we'll just increase it by 1 every time. So yeah, so let's find, so what, okay, let's, oh my god, let's find the number of documents, number of docs which contain, okay, word, say a wi, any word. Okay, let's make it more cleaner. Oh my god. Okay, so we are up again. So now what we should get, okay, so what we should get is okay, let's start to iterate it again in doc list. Okay, then for word comma whale in doc dot items. Okay, If val is greater than 0, we should see a idf dict, okay, of that word. We'll increment it this time, equal to 1. Okay, see, after this, what I should get as a result is something like this. Control C, Control V. Okay, this girl should be 2. Boy, girl, sorry, good should be how much? 3, and boy should be 2, right? Because the occurrence is the 2. Because let's see here. Here also you can see good is 3 times, boy 2 times, and girl 2 times. Actually we are finding out this only, right? Like in each sentence, total number of sentences is 3. So the numerator of the idf will always be 3, and this is required because the counter is required because we want to find out in how many sentences that word wi occurred. Okay, so okay, if we print this out, okay, the idf dict. So yes. Oh, who will run the function? Okay, let's see. We can print it out later also. Okay, still let's do it. We are not returning anything though. idf, and we will send the entire word dicts. What was it? Word dict a. Okay, word dict of a, word dict of b, and word dict of, oh my god, sometimes copy paste is also very difficult. Okay, so word dicts will be sending it. Okay. Okay, if I do a return 1, see, we are getting good 3, boy 2, and girl 2. Good 3, boy 2, and girl 2. Okay, my prediction's right. Okay, then let's go forward. Okay, we don't need this. Sure, now what we'll do is we will calculate the idf. Okay, so right, idf calculation. Here we will do is for word comma val, okay, in doc.items, that we will just iterate through the dictionary. Okay, okay, so let's see. We don't need doc, we need idf dict. What I am doing, man. Okay, for word comma val in idf dict.items. Now what we'll do is we'll calculate the idf for each word. Okay, so idf dict and word. Okay, it will store it in the dictionary because we have made it 0 from, like, here we have initialized to 0, so now we'll fill it. Okay, so idf dict word is equal to math dot log base 10 of n divided by, we call it the float of this one, float of val. Okay, val, right, the value. Sure, but this is, as we know, the formula. This is the formula, right? The number of sentences divided by total number of sentences containing the word I. So according to this formula, this is the formula which I have written. But in documentation, if you can see, not here though, if you go to this documentation, TF-IDF transformer, most probably this is the formula that sklearn is using, IDF, to calculate IDF. The TF will be same, the IDF will be different, this one. Okay, so we will see, we will match it with the TF-IDF, sklearn's TF-IDF also, that what will be the answer. Let's see. Okay, so we are just gonna return this idf dict and we will catch it. Okay, so we have caught that idf dict. Now what we'll do is idfs, we'll just see. Okay, so we are getting this kind of result. Okay, so let's see, because good is 0, boy is 0.17 something. Okay, so okay, let's match it here. So log 3 by 2, log 3 by 3, and log 3 by 2. So log 3 by 2, okay, we will see who it is and how much it is. Okay, log 3 by 2, we are gonna calculate it. Let's go. Okay, 0.176091, blah blah. So I think we are getting the same results as this. Okay, so we have got our idfs right now. So what we'll do is just combine it. Like this time we will take this markdown and we will just write it in a bold that we are calculating the TF-IDF. Okay, so TF-IDF is equal to, so def compute the TF-IDF. Okay, so this time we will take, the TF bows, this one. Okay, so TF bow, I'm really sorry because we're gonna pass it the list of this one every time, and we'll do this TF bow and IDFs we are gonna know. Okay, we'll need this one. Okay, so TF IDF will make a dictionary, sorry, double dictionary. Now TF IDF is equal to, okay, so let's do this again. Word comma val in tbow, sorry, TF bow in TF bow dot items. Okay, so we're getting this out, and TF-IDF word is equal to, oh my god, okay, is equal to val into, where is into, yeah, IDFs of word. This should give me the result, I hope so. Let's see. If it does not, we have to optimize it. Let's see. Return TF-IDF. Right. I'll still copy paste. Okay. So let's see this one as TF-IDF. Okay. So TF-IDF BOWA is equal to, we'll be sending this right straight out the mark. TF-IDF bow A. We're gonna copy paste this same thing. So let's see, yeah, so TF-IDF bow A, bow B, and bow C, and this will go bow B, bow C. Right. Okay, then I think we are done. We can somehow check this. What is this? 0.880 something. Okay, not an issue. I think it will be better if we just do it in pandas. Import pandas as pd, okay, and pd dot data frame, sorry, let's go put it in this one. Okay, as a list you have to put it. So TF-IDF, all the TF-IDF bow A, bow B, bow C. So let's take it bow B, oh my god, okay, bow B and bow C. So here we go, let's run it. Correct, so we are getting this as a result. Okay, so let's match it with this part. Okay, let's see if we're getting the right results or not. So somehow let's see, for girl it is 0, then 0.088 and 0.058 something. So 0, this will be 0, and 1 by 2 log of 3 by 2, right? So we will check this out always. Let's see. Oh, sorry. Control V, 1 by 2. Come on. Okay, like my internet, I think connection is very slow. I don't know, because, but you can always find out. You'll get this same result here. Okay, you'll be getting this same result. See, for good it is all 0. For good it is all 0, because log 3 by 3 we'll get 0 only, right? And oh my god, this will be okay. 1 by 2, 1 by 2, 1 by 3. Okay, for this one is for, right. This will be log 3 by 3 here. Okay, yeah, now because for good it is log 3 by 3 here. Okay, for good it is log 3 by 3 for all. So yeah, so 1 by 3, so log 3 by 3 is always 0, so you get this 0. So most probably this is right, and boy is 0.88 and this is 0, then for boy is 0.88, then this will be 0 and this is 0.05 something. Okay, so we are done with this one, but how will we know that it is giving me the right results? Like if we know that TF-IDF vectorizer escalons is giving me the right results or not. Let's see. So we will take the same documents into consideration. Okay, doc A, doc B, and doc C. Okay, so from sklearn dot feature extraction dot text import t import tf idf vectorizer. Okay, I think this is not in capital tf idf, right? So here we go, and then we will just fit this. Okay, just define the object, vectorizer object, and then fit it. tf idf is equal to tf idf vectorizer, and let's see, response is equal to tf-idf dot fit transform. We'll just fit and transform into the corpus, and the corpus will, let's just you know pass it in the form of list, all the documents, doc A, doc B, doc C, right? Okay, so I think we are done with this one, and then if you want to view the results again, so just you can do this part, right, a pd.data frame, but we will change this to response dot to array, and we'll get the features name of the columns. Okay, so how to get the columns is equal to tf-idf dot, we'll get the get feature names, feature names. So here we go. Oh my god, there's some error. Oh my god, this is not small, this is capital, and tf is not, I'm sorry, it is fit. Again, I'm so sorry, typing mistake. Okay, this happens all the time. So see, as you can see, the results are not matching at all. Okay, this is the representation that we got from scratch. Like we have put all the correct formulas we have seen from the presentation. Still I think sklearn is doing something else to get the results, some other vectorization, other mappings, other embeddings. I don't know what it is doing, some other formula of idf. Yes, it is using some other formula. If we try that formula out, then maybe we can try to match with the sklearn. Okay, so it was something here, right? So yeah, let's try this out. So we will be doing this as is it is, and we'll comment this line out, and we'll be doing it on sklearn's formula. So it will be, so I think it was, they have put it some one here. Okay, so math dot, it is n plus 1 here. Okay, and float val, I think there is a bracket. So yeah, so we'll be adding a 1 here, so 1.0, and another bracket and plus 1. So this is the formula that sklearn has been using, right here as per this documentation. Yeah, so they're using this formula to calculate the idf. So let's run it Okay, let's see what we get as output again. So yeah, we are getting IDFs as this, and TF, IDF, we're gonna find out, and this is the result. So okay, so I think we are getting some change in the result than before, because we have changed some changes, minor changes in the formula. So let's check it out with the TF, like the with the escalance part. Okay, so for boy we can see 0.562469, and boy is 0.562887, and then 0, and then 0.374980, so 0.36, somewhere very close we are getting to the answer, right? So yeah, so this is like 0.5050 and 0.33, so this is 0.4343, 0.27, so somewhere very close. So yeah, some modification, some optimization to their problem, to their algorithm they have been making, some like the escalar, and our in like scratch method, building it from scratch was very close. So yeah, this is all for the video, and I'll be uploading more stuffs on interview preparation, which has been actually asked in the interview. In this playlist you can find all those videos. So I think we are done with this implementation, and I hope that you have understood this algorithm, how it is working, and how you are getting the results out of this. Okay, so right, and okay, done. If you have any questions, if you have like you could not understand any part of the code, it was pretty simple, and there is nothing much to think about. Yet if you still are stuck in somewhere and if you want some help, you can always reach out to me in LinkedIn. You will see my LinkedIn, you can see my GitHub, you see all the links in my about section, and you can reach out to me there. And thank you for watching this video. If you like this video, again, you please subscribe to my channel and be tuned, because I am just gonna upload a lot of videos regarding automation, regarding interviews, regarding data science and machine learning, and you'll be learning a lot from my videos. Thank you once again. Bye bye.